Okay, so we want to learn of completing the square. This is important because not every equation or expression can be factorized. So we are going to learn how to handle equations or expressions that are quadratic but cannot be factorized. How to find the value of x or y or z, whatever. Okay, now for us to be able to do that, we must learn a skill, that is how to complete a square. What that means is we are going to be given something like this, and then we need to figure out one number we need to add here. When we add that number, this is going to be a perfect square. What is a perfect square? Okay, think of the x, right? Make this a little better. Let's say think of x plus 4. All right, we square that. If we should open this, we should have x plus 4 times x plus 4. If we expand, we'll have x squared as x times x squared, x times 4, 4x. This is a plus, actually. 4 times x, and then x times 4 times 4, 16. Now x squared, 4x plus 4x is 8x plus 16. Now this expression is a perfect square. So each time we have an equation and expression that cannot be factorized, we'll take out the last number, the constant. There will always be a constant that you need to multiply to the coefficient of power 2 and get your product number. There will always be. So you take it out and try to think of a number you will add there to make it a perfect square. And every perfect square can be factorized into something like this. 1 bracket with the power 2 up. So first of all, I'm going to prove how to get this. There's a shortcut, but I'll go the long way first. Now I'm going to go the long way with this. So I'm thinking of a number I should add here, assuming the 16 was not given, I just add x squared plus 8x. You'll get the usefulness of this process as we proceed. If I just had this like this, how would I have known what to add here so that I'll have a perfect square? So what I will do is, I'll write out the expression and just add k, and I will assume that it will be a perfect square in the form x plus a all squared. Alright, and now open this. When I open it up, I'll just match the values. Just like that, it works. So I'll rewrite this as x plus 6x plus k. I'll say equal to x plus a times x plus a. X times x, x squared, x times a, ax times ax, a times a squared. Alright, equals, I'll just rewrite this, x squared plus 6x plus k. I'll just simplify this a little. Ax plus ax is 2ax. Then I put down the a squared. I bring down the x squared. Alright, now I'll rewrite this again. I think we're ready now to match them. What I mean by matching, for my equal sign. This is this. This is this. And the last one there being k is this. So what this means is 2a is 6, and this x is this x. So if 2a is 6, let me write that 6 properly, it means a is 6 over 2, which is 3. Super easy. If you put 3 here, 3 raised to the power 2 becomes 9, and this becomes k. So a is 3, k is 9. So if I add 9 here, I will have perfect square. So my perfect square is x squared plus 6x plus k. That's it. In place of k, sorry, I'm just supposed to write 9 there. 9. So this is a perfect square. I have figured out what I must add to get a perfect square, and it's 9. 9 is the correct answer. Now, what is the shortcut? If I had divided this 6 here into 2 and raise the answer to power 2, divide by 2 and square the result. 6 divided by 2 is 3. 3 raised to power 2 is 9. That would have just been a shortcut. Okay, and I got this perfect square. All right, a perfect square, if I want to put it in this form, in the square form, I would need to come back here. X plus a is 3. So x plus 3, x 3 squared. If you do that right, you get this. If you expand this, you get this. Simple. All right. So this is a very important skill in completing the square method of solving quadratic equations. And you have a shortcut you can just use here without wasting time. Divided by 2. 8 divided by 2 is 4. 4 raised to the power 2 16. So x squared plus 8x plus 16. This becomes a perfect square. Of course, already there. So when you're given anything at all, just divide the coefficient of x by power 2 by 2 and then raise it to power 2 after dividing. All right, so how does this help us to solve quadratic equations that cannot be factorized? Okay, let's take this example. X squared minus 8x plus 3 equals 0. Let's call this example 2. Now, this particular one cannot be factorized because if you multiply 3 by 1, you get 3. Now you're looking for two numbers, you will multiply to get 3, and then you will add to get minus 8. There are no such numbers, my dear. So what would you do? You remove this 3. Just take it across so that you have x squared minus 8x equals minus 3. Okay? You can't find whole numbers that will do that job for you. So remove this 3. Now see this? Make it a perfect square. Make it a perfect square. You divide this by 2. Since this is minus 8, when you divide by 2, you get minus 4. Alright? You raise minus 4 to power 2, you get 16. Alright, so you say x squared minus 8x plus 16. Now, to make this equation remain an equation, you must add 16 to both sides so that it doesn't look one-sided and become a false stuff. It's no longer an equation. You just add to one side. It's no longer equal. Now we've done this. All right. So what do? We bring all of these over and just simplify it. Okay. So this is a perfect square now. Now let's factorize this and see. Normally, perfect squares, this half of this just works. So let's try. When I say half of this works, it means half of this 6 here is 3. If I just put it in a bracket and raise it to power 2, it works. So let's try it there. Half of this is minus 4. Let's put it in a bracket. X minus 4 and square it. Let's see if this will be equal to this part of the equation only, not the equation. This part of the equation. Let's see if that will work. So x minus 4 times x minus 4. X times x is x squared. X times minus 4 minus 4x minus 4 times x minus 4x minus 4 times minus 4 plus 16. What do we have here? We have x squared minus 8x plus 16. So you see this is same. So this can be used in place of that. So x minus 4 squared, you can always half this and just put it in a bracket with only one x and square it, and it works. And it gives you exactly what you would get when you square whatever you got from the half and add it to the expression. That's just a trick. All right. So this is equal to, let's simplify the right hand side a little, minus 3 plus 16. That should be 16. All right. So now you square both sides, square root both sides to remove the square. So x minus 4 equal root 13. Okay. All right. Now, you see, when you have a square root like this, let's say 16 can be gotten from 4 times 4, and 16 can also be gotten from 4 times minus 4. So when you are saying square root of 16, it could be plus 4 as your answer, it could be minus 4 as your answer. So it's written as plus minus 4. You understand? So here, whatever the answer is plus minus. So there are two values for x. One value for x is gotten when you say, okay, first of all, x equal to square root of 13. When you take this across, it becomes plus. So when you get the value for square root of 13, x can be equal to the positive value of square root of 13, the positive part, plus 4, or the negative part of square root of 13 plus 4. So these are the two possible answers for x. How could you have gotten a square root of 13 as a whole number if you were looking for two numbers that you add and multiply? You see, this is why completing the square is very, very important. You need a skill which you can use the shortcut and run it down this way. Super easy.